In this video, we'll be learning how we can seed data into our users collection. Seeding is just the process of populating our collections with some data programmatically. So in our previous video, we saw how we were able to create a model class for our user schema. And then using that model class, we were able to create a new document instance, just like the code snippet that's being shown on the screen right now. So what we did was we imported the user module, and then all we did was created a new user instance and passed a user object in the constructor. Now this user object had all of the necessary fields that we defined in our user schema, and then we stored this new document instance in a variable called user. And to insert this user or save this user into our collection, we call the user.save method, which, as you can see here, is a document method. So we can insert documents using the save method, and for that first we have to create a new document instance of a model. So we'll have to first instantiate the user class by typing in new user and passing a user object in the constructor. And then once the user instance is created, we just need to call the save method on top of that user instance. So the save method returns a promise where we can either use a then block to handle the fulfilled promise or use the await keyword to wait for the promise to be resolved. Now, one thing to remember is that no document will be created if the connection to the MongoDB instance is not open. So you might remember in our function here, which we use to create a new user, we first connected to the Mongoose database using mongoose.connect, and we pass the connection string as a parameter to it. So only after a connection has been established, you will be able to create a new user using the save method. Now, one very important thing here is that save is a method of the document object and not the class itself. But let's also see what other methods can we use to insert a document into a collection, and maybe one of these methods would be a better alternative for our seeding scripts. So next up, let's see the create model method. Now remember that this is a model method. It is exposed by the model class itself. So it's a static method which is attached to the model class, and we can directly call it on the class instance as shown in the code snippet here. So we're calling user.create, where user is the model class. We mentioned the same here, that create is used on the model class and not the document object like we did in our save method. Now create also does the same job. The only difference here was that we do not create a document object first. We directly pass the object as a parameter to the create function, and then the method takes care of the rest. Now again, create returns a promise, so we can either use a .then block to handle the fulfilled promise or use the await keyword. Both will work, and obviously no document will be created if the connection to the MongoDB instance is not open. So let's go ahead and test our create method. We'll go back to VS Code. Here we'll copy the same object and comment out the code that was creating the user. So we'll comment all of this out. Now, instead of creating a document object and then calling the save method on it, we'll directly just call the user.create method, to which we'll pass the same object as a parameter. Now, since this is an asynchronous operation, we'll add the await keyword in front of it and store the response in a variable called result. And then in the end, we'll just console log the result value. Let's go ahead and run the script in the node environment. But before that, let's go ahead and check what's there in our collection. So there is just one entry which we created the last time. Let me just refresh on the collection. And since then, no other document has been added. We'll execute our script by typing in node, the name of the script, which is Mongo test, and hit on enter. And in the terminal logs, you'll be seeing that we're getting a similar object with the same first name, last name, and email ID. And the only difference is that we have a new object ID this time. So if we go back and refresh our collection, you'll see that a new document has been added, which has the exact same data. Now this might be a problem for us. There might be a case where two people have the same first name and last name, but email is something that is unique. And this is something which is very easy to implement. All we need to do is go back to our user model, and here in our schema for email, we'll add another attribute which is called unique. Now for those of you who have already worked with the MySQL database, this is exactly like the unique constraint over a MySQL table column. All we need to do here is add a unique key and set it to true. We'll save our changes. In the collection, we'll also delete our newly created entry. Hit on the delete button, go back to VS Code and try running the script again. Now remember, we have added a unique constraint over the email. So this time when we try to create the same user again by calling the same create user function, where the user object hasn't been changed, and now when we run the script, you'll see that this time we're getting an error back. Now obviously we did not have proper error handling in our create user function, which can be done easily by just wrapping our code in a try catch block. So we'll do that in a while, but let's see what the error says. You can clearly see here that the Mongo server error is complaining that a duplicate key error was encountered. And it's exactly mentioning where things went wrong. That for our email key, the value of which we entered as abc@xyz.com, we are violating a unique constraint. So obviously, if we just change our email ID to something different, let's say jane@xyz.com, and also change the first name to something else, we'll run our script again. And this time we have successfully created our new user. Let's go back to Compass, refresh, and we are seeing the new entry with the email ID jane@xyz.com. Now, as I said, it's always a good thing to wrap your function in a try catch block so we can handle the error properly. I'll move all of our code inside a try block, and then we'll have a catch block to catch any errors that occur. Here we'll just simply console log the error, and that's basically it. Now we saw how save and create work. There is also a third method called insert many, which is again a static model method. So insert many is a static model method used to insert multiple documents into the collection at once. This is the most ideal function or method that we can use to write our actual seeding scripts. All we have to do is call the insert many method on the user model and pass an array of user objects. So as you can see here, we're passing two different objects, and then we're awaiting for the batch insert to finish. Now we'll go back to VS Code and see how this works. We'll remove all of our previous code, and here instead of create, we'll be calling the insert many method. Now if I hover over it, you'll see that it inserts one or more documents as a single insert many call to the MongoDB server. Instead of a single object, we'll pass an array of objects this time. So we'll enclose our document object inside an array, and we'll also pass multiple objects in this case. We'll add a few changes so we do not violate our unique constraint. So I'll add a few changes to the documents that I'm inserting. And that's basically it. We are now passing an array of objects which match our user schema. Let me just collapse this whole thing. We have added the await keyword in front of user.insertMany, and we're storing the response in the result variable. Now this time, since we're making a batch insert, instead of a single object in response like we were getting before, this time we'll get an array of objects in the response. So let's go ahead and test our script. And before I do that, let me also just delete all of the documents that were there in the collection so that it's empty. And now we'll run our create user function again, which now can be renamed to seed users, because now we are inserting multiple user documents as a batch operation. So we'll rename the function to seed users, and we'll be calling this very function in the script. We'll also rename our file to users.js, and we'll create a new folder which we'll call seeds and move our user seed script inside it. Now we'll call our seed script from the node environment. So we'll say node, and now the folder structure has changed. So we'll be calling user script from within the seeds folder. So we'll say seeds user.js. And as you can see, this time in the console, we're getting an array of objects back. And there are in total 3 objects, each one of which represent the objects that we passed in the insert many function call. And if we go back to our MongoDB Compass users collection and refresh, you'll see that 3 new entries have been created in the MongoDB database. Next up, we'll dive a little bit deeper into the connect function and see how we can create a connection pool.